Hello, Math 1020 class. Let's do Chapter 1 review for the final. The table below gives a country's median age at first marriage for selected years from 1890 to 2009. And the first part says, find F of 1890. And it says F is the median age at first marriage for men. So you really just have to look in the table under the men column for 1890, and it looks like it's 27.1 in my particular assignment. But just remember, this is function notation. This is the x value, and the f of is the y value. So they also want 2004 for the men, which is 27.2. But that's easy. Part G, it says, if the function G is the median age at first marriage for women, find G of 1940. So once again, it's just function notation. That's the x value, this is the y value. But G of 1940, you just have to look at the second column, the women column. It looks like 21.8 to me. Your numbers are probably going to be a little bit different, I assume. But this one's kind of an easy one. G of 2000, for me it's 25.4. And it says, for what value of x is f of x equal to 24.8? So we really just have to solve this thing for x. And just remember, f is for the men. So look at the men column and try to find 24.8. And I see 24.8 in 1980. And let me see if there's any other 24.8s in there. I don't think so. So it looks like the answer is 1980. So they give us the y value and they ask us for the x value in that case. Did f of x increase or decrease from 1960 to 2009? So that's for the men. Just look to see if the y values for the men went up or went down from 1960 on. It looks like it went up, so it increased. Not surprisingly. The median age for marriage tends to go up over time. Alright, let's do number 2. The revenue from the sale of specialty golf hats is given by the following function. Where x is the number of hats sold. What is R of 300? And then interpret the result. Well, that's easy. Just plug in 300 for x. So this goes back pretty far. This is just basic function notation stuff. But all it means is if we sell 300 hats, we get a revenue of $6,300. We bring in $6,300. What is the revenue from the sale of 2,000 hats? And this is part B. And it says something like R of what equals what on my computer. Well, remember in this particular problem, the x value is the number that you sell. So the 2,000 has to go over here where the x is. And for the y, we'll just plug in 2,000 into the function right there. Real easy. And I get 42,000. So we bring in $42,000 when we sell 2,000 hats. The percent P of high school seniors using marijuana daily can be related to X, the number of years after 1990, by the following equation. Find the x-intercept of the graph of this function. Just think of the p as the y in this case. It's kind of like a y. So if I wanted to, I could replace the p with a y, but I think I'll just leave the p in there. But remember, if you're looking for the x-intercept, you set y to 0. But in this case, the p is the y, so I'm going to set p equal to 0. So this whole term will go to 0. And I guess I just need to divide both sides by negative 19. Part B. Find and interpret the p-intercept of the graph of the function. So first find the p-intercept. That's kind of like the y-intercept. You want to set x to 0 this time. So that'll make this term go away, and we'll get 27p equals 27. Divide both sides by 27, you get 1. So what does that actually mean? Well, when we set x equal to 0, that really corresponds to the year 1990. Because x is the number of years after 1990. So it really just says in 1990, 1% of high school seniors were using marijuana daily. And I don't want to write all that out, I'll just say it verbally. And then we're supposed to graph this thing. And I think we're talking about this equation up here. 27p minus 19x equals 27. So I suppose what you could do is just solve for p and then plug it into your calculator. That's kind of easy. And really, it's a multiple choice problem, so I could probably choose the right answer without even doing that much. Notice the slope is positive, so the line is going to be going up, and it's got a y-intercept of 1 there. So roughly speaking, it's going to look like that. So it looks like it's probably A in my problem list or answer list. One more part of this problem. What x's on the graph represent years 1990 and after? Well, remember, x is the number of years after 1990. So whenever x is bigger than or equal to 0, we're going to be in 1990 or later. X bigger than or equal to 0 is the answer to that part. That corresponds to years 1990 and later. Let's do number 4. Use the given conditions to write an equation for the line. This one goes through negative 3, 8 and is parallel to the following line. 3x minus 2y minus 7 equals 0. So this is a good one. It's been a while since we did these kind of problems. But if the line we're looking for is parallel to this line, it's going to have the same slope. So how do you find the slope of this line? Just solve for y and look at the coefficient of x. So I'm going to leave the negative 2y on the left side of the equation, bring over the 3x, make it negative, bring over the negative 7, make it positive, and then divide both sides by negative 2. And this is what you get. So notice the slope of the line is 3/2. But the line we're looking for is parallel to it, so it's going to have the same slope, but it's got to go through negative 3, 8. So now we have the slope of the line and a point that it goes through. So to actually come up with the equation of the line, I could just use point-slope form. So that's something you should know for the final. y1 in this case is 8. It's the y-coordinate of that point. x1 is negative 3. Be careful with the negatives. You really have a double negative there. That'll turn into x plus 3. Now distribute the 3/2. And that'll actually turn into a 9/2 because it's really 3 times 3 over 2 times 1. And the very last step, add 8 to both sides. So I'm just going to use a calculator for that. And I get 25 over 2. So that should be the equation. Let's do number 5. Write an equation for the line shown to the right. So let me give you the sketch that we're given. And they actually give us a couple of points highlighted on the line. One of them appears to be 0, 5. And the other one appears to be 5, 4. Okay. Well, here's one way to do it. There are actually multiple ways we could do this. I'm going to use slope-intercept form, though, because notice we're given the y-intercept is 5. We're given the b. So right away, I need just the m now. So how do I find the m? Well, if 5, 4 is on the line, it's got to satisfy this equation. So I'm going to replace the y with a 4 and the x with a 5. And I'm going to solve that thing for m. And when I do, it looks like I get negative 1/5. So my equation turns into negative 1/5 x plus 5. That's just one way to do it. Could you do it other ways? Certainly. So don't think that you have to do it my way. As long as you do it a correct way, it's fine. You know, the other way to do that, I suppose, or another way, is just find the slope from the 2 points, and then you have a point and the slope, and then you can plug that into point-slope form. Well, let me go ahead and do a Chapter 2 review on this video also. I plan on doing 2 chapters for each of the 3 video reviews for the final. Unless one of them just happens to have a lot of problems. Well, let's do this one, number 1. My equation looks like this. 3 times x plus 3 equals 5x plus 13. So just kind of an easy linear equation. First thing to do is get rid of the parentheses by using the distributive property. So 3 times x, 3 times 3. Now let's put all the x's on the same side. So I'm going to subtract 5x from both sides. And then let's put all the constants on the right by subtracting 9 from both sides. And the very last step, divide both sides by negative 2. So again, I go fast, but just pause the video if you want to slow down a little. Solve for t is this one. So on that kind of problem, I have to tell you which one to solve for. But let's go ahead and distribute the d on the right-hand side to get rid of the parentheses. And then let's get rid of that d right there by putting it over on the left, or subtracting d from both sides. And keep in mind that we're solving for t, so we've got to get rid of this thing. And let's get rid of it by dividing both sides by it. To get a B in math, Alexandria Pappas must average 80 on 5 tests. And here are her first 4 test scores. What is the lowest score that you can get on the last test and still get a B? Well, let's let X be the 5th test score. The average of all 5 tests will be this. It's the sum of them divided by 5. I just don't happen to know the last one, so I just have to write it as an X. But I want that average to be at least 80. So plug all that into a calculator, you get 315. Now multiply both sides by 5. It'll cancel out the 5 on the left. 8 times 5 is 40. Lastly, subtract 315. I'm sorry, that's an 80 there. So that's a 400. Now subtract 315 from both sides. And it looks like 85. So she's got to get at least an 85 to get a B. Okay, so this one looks like kind of a calculator problem. As the table shows, projections indicate that the percent of adults with diabetes could dramatically increase. So I think I might skip this one. It's a calculator problem. I might do this on a different video. Well, let's do number 5. A promoter needs to make $89,300 from the sale of 2,000 tickets. She charges $38 for some tickets and $57 for others. So I guess the $57 tickets are closer to the stage. And X is the number of $38 tickets. Y is the number of $57 tickets. Part A says, write an equation that states that the sum of the tickets sold is 2,000. And on my computer, I just get something that looks like this. Well, the sum of all the tickets sold is just X plus Y. So that's it. Write an expression representing the amount of money received for the sale of X tickets for $38 each. That's just 38X. And not surprisingly, how much money do you take in when you sell all Y $57 tickets? 57Y. Write an equation that states that the total amount of money received from the sale is $89,300. So I see something like this on my computer screen. But all you really have to do is say, well, I get this much money from the $38 tickets, I get this much money from the $57 tickets, and that sum has got to be $89,300. So they were kind of forcing us to come up with a system of equations step by step. And now we actually have to solve the system. So let me rewrite it. We had 2,000 tickets, and then we had this second equation. So here's our system. So how are we going to solve this system? Well, we could use elimination. I'm just going to multiply the whole first one by negative 38. And we'll leave the second one the way it is. And divide by 19 to get y by itself. So it sounds like we're selling $757 tickets. But remember, the total number of tickets sold is 2,000. So I guess X would have to be 1,300. It says solve the inequality graphically by the x-intercept method. But I think we've mostly done this algebraically, so that's the way I'm going to do it. So distribute the 6 first, and then distribute the 9. You can pretty much get x by itself using the same method that we use when we solve a linear equation. I guess at this step I would subtract 18 from both sides. And I'm going to divide by a positive 3, so I don't have to flip this thing around. I only do that when I multiply or divide by a negative. And they want this in interval notation, it looks like. So it's everything to the right of negative 12. So there's the graph of it. In interval notation, that's what it would look like. Last problem on this video, number 7. Deb Cook is given a choice of 2 positions, one paying $4,000 per month and the other paying $2,400 per month plus a 5% commission. What amount must she sell in a month for the second position to be more profitable? So on this one, you want to let X be the sales, the number of dollars in sales, and you want the second one to be more profitable. So this is what you would set up. So this basically just says, when I take my base salary and add 5% of sales, that's the total salary of the second position. And that's got to be strictly bigger than the $4,000 for it to be a better job. So just solve this thing like you would solve for X in an equation. I would start by subtracting 2,400. And now to get X by itself, divide by 0.05. And I don't have to reverse the direction of the inequality symbol because I'm not dividing by a negative. It doesn't matter that it's less than 1. The only thing that matters is that it's positive. So when I plug that into a calculator, she has to sell more than $32,000 in merchandise in order to take the commission job or for it to be more profitable. So that should do it for this first video.